All right, guys, let's knock out this review video. Number one says graph each of the following exponential functions. First of all, number one is exponential growth because there's a 2, which is bigger than 1. There's no shift up or down, which means the asymptote is at 0 right there. Going to go up 1, but there's an x minus 3 in the exponent, which means since it's inside, it moves left, right, opposite what you think. So I'm going to go right 3. So my first point's going right there. Then I didn't do a very good job there. Okay, right there. Then I always go 1 to the right of that point. Okay, so I'm going to 4. If I plug in 4 up here for x, 4 minus 3 is 1. That's why I go 1 to the right every time, because it always gives me 1 in the exponent. So 2 to the first power is 2. Second point's at 2. That's really all you need right there. Also, I want you to go ahead and tell me 3 things. Tell me the domain, which is all reals. Tell me the range, which is from 0 to infinity. And also tell me the asymptote, which is y equals 0. I should have put that in directions. Number 2. This time it's exponential decay. A couple things going on here. First of all, there's a minus 2, which is a downshift 2, which means the asymptote is down at negative 2 instead of at 0. The negative in the front is going to reflect it across that asymptote, so it's going to be going down. There's no shift left or right, but there's a negative x in the exponents, which shifts it across reflects it across the y-axis. So there's all kinds of stuff going on here. Now, 0, there's no shift left or right, so normally I'd go up 1, but because that negative's still in the front, I'm going to go down 1 from the asymptote right there, which puts me at right there where I put that point, 0, negative 3. Now, I'm always going to go 1 to the right. So if I plug in 1 right here for that exponent, think about what happens. That makes the exponent negative 1, which flips that point to makes it 3. The number inside, sorry, 3. But it's really a negative 3 because of the negative in the front, and a minus 2, which is negative 5. So I'm going to go down to negative 5. I'm having a hard time seeing that, which is like right there. And then I'm going to draw the graph going just like this. So it's basically exponential decay, but really growth because of negative that's been reflected across the x-axis and shifted down too. A lot of stuff going on there. So my domain, as always, is all reals. My range is from negative infinity up to negative 2, and my asymptote is at negative 2. Perfect. Number 3, a certain breed of mouse, we talked enough about mice this week, was introduced onto an island with an initial population of 250 mice, and scientists estimate that it's doubling every year. Find a function that models the number of mice after t years. So the model is just going to be y equals a. Remember, a is the initial amount. The function looks like this, by the way. All right, so the initial amount is 250. It's doubling, so I'm going to go with the 2. The time is t. There's your function. Part B says estimate after 8 years. So all I'm going to do is I'm going to put in an 8 for the time. I'm punch it straight into my handy dandy calculator. And when I do that, I'm getting 64,000. That's a bunch of mice. Wow. And the second part is we did a lot of interest, a lot of money talk on Tuesday. And here we go. It says investment of $8,000 is invested at a rate of 4%, compounded quarterly. Find the value after 7 years. Again, this is not a lot of years, okay? And it's only 4%, so don't expect a miracle here, but still going to make some money. Okay, 4%, I'm going 0.04. It says compounded quarterly. Quarterly is 4 times a year. My exponent is going to be 4 times 7 n times t. Now, that's really 28. So when I punch in my calculator, I'm going 8,000, 1 plus fraction, which is 0.04 over 4. All that raised to the 28th power. And I'm getting 10,000. Make sure you get this too. $10,570 and 33 cents. Number 5. Well, would that be the value of the investment? Should we say number 4? If the interest rate was 3.6%, compounded semi-annually. So the same problem, except changing a couple of things here. So I'm going to go. The final amount would be still starting with 8,000. Still have the 1. Now my interest rate is 3.6%, even lower. N is how many times a year? So semi-annually, that's twice a year. My exponent is going to be 2 times 9 or 18. Remember, the exponent is n times t. Let me punch that in. And I'm getting $11,029.35. Looks good. Now we go to review. So here we go. Number 6. Find out polynomial degree 3 that has zeros 4 and 2 monoside. Now if it has 2 monoside, don't forget, that also means it has 2 plus. Come on. means it also has 2 plus I. So don't forget that. So when I set it up, I'm going with the x minus 4. I forgot the b of x. B of x equals x minus 4, x minus 2 minus I, and x minus 2 plus I. And here we go. I got to work it all out. Leave the x minus 4 to the end. I like to do conjugate, but before I do that, I'm going to distribute the minus sign, so make it x minus 2 plus I, and also x minus 2 minus I. And that's where the conjugates come from. So I have x minus 4. Now you have two choices here. One thing you could do is you could take this x and go all the way through there. You could take that negative 2, go all the way through. Take the I, go all the way through, and then add what you can. So if you don't understand what I'm about to do, that's the method you could also use. I like to do the conjugate method better, meaning they both have x minus 2, that's the first, and they both have a plus I and a minus I, that's last. So I'm about to do the conjugates through foo. So if I do first last, I'm going to get x minus 2 squared minus I squared. All right, still saving that x minus 4. Inside my bracket or parentheses, I'm going square, multiply together, double, square. And that minus I squared is really a plus 1. Now, everybody knows 4 plus 1 is 5, so I'm going to erase that 4 and 1. Replace it with a 5. Now, what I have to do is distribute. I'm going to start with this x in my first parentheses, take it all the way through. That's going to be x cubed minus 4x squared plus 5x. Now, I'll take the minus 4 through, minus 4x squared plus 16x minus 20, and I'm just looking for stuff that they have in common. So looking for like terms. X cubed minus 8x squared, because I saw that in that. There's a 5x and a 16x, that's 21x, and I have the minus 20 at the end. And that's all you gotta do on that one, okay? No big deal. Now, I hope you saw it, because I'm about to erase it so I can make room for number 7. That took a lot of room right there. Hope I can erase it. There we go. Number 7, simplify this imaginary, division of complex numbers. Here I'm multiplying by the conjugate, make it a little bit bigger. There we go. The conjugate of 3 plus 4i, 3 minus 4i. Multiplying the numerator and denominator by 3 minus 4i. My denominator, I'm doing foo. 3 times 3 is 9. Positive 4 times negative 4i is negative 16i squared. I squared is really negative 1, which makes that negative 16 become positive 16. That's 9. That's plus 16 is 25. Now I'm doing FOIL for my numerator. 5 times 3 is 15. Outer is 20i. Inside is negative 3i. Last is plus 4i squared. I squared makes that 4 negative 4. So 15 and negative 4 is 11. And if I add the negative 20 and the negative 3, oops, it will give me negative 23i over 25. And there's 7. Number 8, factor completely. Find all zeros, take the multiplicity of each. All right, factor completely. First of all, that's cubes. So I'm going small, big, cube root. So small, big, cube root, square, the first. Multiply together, change the sign, square. So here's what I know right now. One of my zeros is x equals 3. That came from that first factor. What I need to do is I need to take this quadratic right here, the x squared plus 3x plus 9, and come over here and stop it. So I'm going to go quadratic formula because it's an odd number in the middle. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Inside, I don't know if you noticed this or not, I have 1 9 minus 4 9s, which is negative 3 9s, or negative 27 over 2. I got to break down that negative 27. First thing I got to do is, obviously I'm going to take out an I, but also 27 is 9 times 3. Square root of 9 is 3. I can't break down the other 3, so I get that right there. There's my other 2 zeros. And so it says find all the zeros. So those 2 and the 3 are all the zeros. But it also said factor completely, so don't forget to do this step. You got to write as factors x minus negative 3 plus 3i on 3 over 2. And also I'm going to run a room right here. X minus negative 3 minus 3i on 3 all over 2. Sorry about that. Just ran right over. Hope that helped. Number 9, divide. The question becomes, can you do synthetic? The answer is, oh yeah, you can, because the bottom is a first degree binomial. I wish I could talk. 1/2 goes in the box. I got a 2, a 0, a 3, a 0, a negative 1. Don't forget those zeros. Bring down the 2. Half of 2 is 1. Bring that down. Oh boy. Half of 1 is a half. 3 plus a half is 3 1/2, and 3 1/2 is really 7 halves. 1/2 times 7/2 is 7/4. That's going to be 7/4. Half of 7/4 is 7/8. And by the way, -1 is really -8/8 plus 7/8 is going to be -1/8 for my remainder. So don't forget to write your answer. Because I started with degree 4, my quotient is going to start with degree 3. 2x cubed plus 1x squared plus 7/2 x plus 7/4, and my remainder is 1/8 over x minus 1/2. There's you should end up. Number 10, graph that thing. Graph that function and tell all this stuff. Okay, so I'm going to go ahead and do this. Really, I'm going to factor the numerator first. It's really 3 times x minus 1 over x minus 2. Remember, vertical, whatever makes the bottom 0. So the vertical asymptote, I'm going to write this stuff over here. The vertical asymptote is x equals 2. So I'm going to do the vertical right through here. There's the vert. Horizontal has 3 rules. This time, the degrees are the same. So I'm doing leading over leading, which is 3. So I'm going to y equals 3, which is right through here. Looking good. The x-intercept, whatever makes the numerator 0, which is 1. The y-intercept, cover up everything, all your x's, and it leaves you 3/2. So I'm going to put those points on the graph. The x-intercept is 1, which is right here. The y-intercept is 3/2, which is 1/2, which is right there. Once I put those points there, I already know this part of the graph is going like this. I've just got to figure out what the other side is doing. So I'm going to punch that in my calculator real quick and see what the other side is doing on the other side of the vertical asymptote. And once I put that in, I'm seeing this curve right there. Also, don't forget to tell your domain and range. Tell everything you know. The domain, left to right, is everything except for the vertical asymptote, which is at 2. That's how you write that. And your range is everything except the up and down, everything except the horizontal asymptote, which is at 3. Just like that. And you're good. So, number 11, which is the last one, I think. It is. Sketch the graph of the following function. Make sure your graph shows all intercepts and proper in behavior. First of all, one thing I noticed, well, let's do zeros first. +2, -4, +1. So +2 is here, -4 is way over here, +1's right there. None of them are squares, so there's no bouncing. Because there's 3 x's, that means it's odd. And there's no negative sign in the front, so it's odd positive, which means it's going to go down, left, and upright. That's what it's doing. Also, don't forget your y-intercept. Your y-intercept, remember, cover up your x's or put in zeros, which will leave you this. It will leave you a -2 times a 4 times a -1, which is +8. So the y-intercept is way up at 8. Don't have my glasses, I think is right there. So I'm starting down there to the left, coming up through that point, hit your y-intercept, come back down, back up. It's gonna look something like, that's not very good. That's really terrible. I'm gonna try one more time. That's a bad looking graph. Let's see if I can. Okay, coming up through here, hit that one, back down, back. That's not much better. A little bit, I guess. All right, there you go. It's got the in behavior. It's got all your intercepts. Looks great. That test doesn't seem that bad to me. I hope you have a great grade on Thursday and have a nice long weekend knowing that you did great on your pre-cal test before you left. So see you tomorrow.